Hello everyone, I'm welcoming you all once again to this channel. So in this session of Fortran programs, we will use our do loop to find out the Fibonacci series. So let's start. So before starting this, let's understand what is Fibonacci series. So here is like if we are having this kind of numbers, so what will happen, like 0 and 1 will first added up, and then the next number will be the sum of that addition, that is 0 plus 1 is 1, and this is the result. And next will be 1 plus 1 is 2, and here is 2. Next is 1 plus 2 is 3. So like this series will go on, and as we can see that this will be a never ending series, but we can terminate it up to a certain level. So let's go and see our code. So here the first code I have written here, that the program is written with Fibonacci series, and here it is started, and the integer data type that we have taken is I, N, A, B, and the result. And here the N is the number of steps up to which it will count, like it will do that series performance. And initial number we have taken, that is A, that we have taken as 0, and B as 1, like first two element of that series, 0 and 1. And next here these are our do loop variable, like the I is the do loop variable, and I started from 1 and up to that series length, and here N is 10, and initially it will print the result A, and like the result will be A plus B, that is nothing but our first two term addition, and that result will be A, like A equal to B, and B will be the result. So this way it will add B to every time it will take B as A and result as the B. So this way it can go for the addition up to when the series will go, and then we can end this program. So let's try to execute this. So I am running it here. You can check that this is 0 1, and 1 0 is 1, and 1 1 is 2, and 1 2 is 3. So this way it is continuing. But what if I will change this number n equal to 10 to n equal to 100? So let's see what is happening here. So I am changing this n equal to 10 to n equal to 100. So let's run this. So now we can see that this series is continuing, and here at certain range it is giving us some negative values. That means like the system is not able to perform this series compilation correctly. So what can we do? So for this we can do certain modification. So let's go to our second program. So here is our second program. So here what we have written, that we have taken a double precision. So here in the earlier code it was only integer, but here I have taken kind 8, that means a double precision thing it will take. And the same thing here we are doing, but here we have given another condition, that if B is less than 0, then it can execute, like it can stop the operation by writing the overflow occurred. So let's see after running this code. So I am running it here. So you can see it went up to 92, like the overflow occurred at the term 92. That means at 92 step of this do loop the overflow is started. That means some negative value is coming. So that means what we can see, that when there is a 64-bit compiler and it can't execute this Fibonacci series above 92 steps. So for this, to make a generalized code, what changes we want to do? We don't have to do all these, and we don't want our prevention at any point, because we have given n equal to 100. So we want to execute it up to 100 steps. So for this there is a solution. So the solution is what? So here instead of integer, as we can see our previous code, this was integer. Here we have taken real data type. As we know that integer can take very less terms, rather real data type can take up to 10 to the power 308 something, like something numbers that it can take. So that means there won't be any such issue. So let's see, after executing this same code with no, like instead of integer we have taken real kind of data type. So let's see and execute. So here I have already executed, and still here you can see that the Fibonacci series started like this, and it is running, and it is running up to 100. So this way, if we will do some changes and we can try with different data type, then we can get our result. And this way we can perform anything using our do loop. And this much for today's session, and thank you all, and bye bye.